Here is an explanation for the answer to final exam, question number 97 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find this question split between pages 438 and 439. We're talking here about a sine wave with an angular frequency of 2,261,947 radians per second. And we're asked to figure out what its conventional frequency is in hertz or kilohertz or megahertz or whatever. Remember that the period of a wave is the length of time it takes for one complete cycle to occur. That's 360-degree cycle. The angular frequency is the number of radians per second. So we're talking here not about the number of full cycles that we get per second, but the number of angular radians that we get per second. A radian is 1/2πth of a full circle. So if we want to figure out, say if we know the conventional frequency of a wave and we want to figure out its angular frequency, we need to multiply by 2π, because there are 2π radians for every full cycle. If we want to go the other way, we know the angular frequency and we want to figure out the conventional frequency, we need to divide by 2π. So let's do that. Let's just go ahead and do that. We'll input 2, 2, 6, 1, 9, 4, 7. Let's divide that by pi. Now we're given pi here in the question as 3.14159.265 approximated. This calculator goes further than that, so we're going to get an even better answer than that. Now we're dividing by pi here. We need to first do that, and that gives us 720,000 hertz. But we need to divide by 2π, not by pi, so we need to turn around and divide this again by 2, giving us 360,000 hertz, or 360 kilohertz. So that is the conventional frequency, 360 kilohertz, rounded down, because we had a whole bunch of extra digits in our calculator result, but we can round that to 3 significant figures, 360 kilohertz, and that in this question is choice E.